Welcome to Spring LIB.
Okay, we are starting with an aldehyde. And ending via some number of synthesis steps with an alkene. And what I will point out first, and is a really good thing to do anytime you do a synthesis question, is count the number of carbons you have in your starting product. Here we have 7, and then count the number in your final product. We have 8. So we know at some point we formed a new carbon-carbon bond or did some sort of reaction that increased the number of carbons by 1. And the reason I mention that is because right off the bat, that tells me that we must have used, from the list of reagents that we have, methyl magnesium bromide, because that's the only reagent on our list of reagents that is capable of increasing the number of carbons by exactly 1. So I know that somewhere we used B, which is methyl magnesium bromide. Followed up with acid hydrolysis. Okay. Maybe right away, maybe later. Well, what's interesting is that now that I've realized we need to use methyl magnesium bromide, I noticed that, well, using it right away is actually perhaps somewhat useful. Because if you recall, what methyl magnesium bromide will do is it will act as a nucleophile and convert an aldehyde into an alkoxide while forming a new carbon-carbon bond. That's that if we look at our first reaction. If we do B, what we will end up with is a new carbon-carbon bond to a methyl group and now a secondary alcohol. Wonderful. Okay, so now really all we've got to do is perform some form of elimination, right? Specifically one that will generate, and this is important, eliminate an alcohol, but give us the less substituted alkene, right? If we were to try to use, say, acid and heat, we would generate an alkene here, but we need to generate an alkene here, so we need to be a little more clever about the elimination that we need to perform at this point. Notice that we have access to tosyl chloride. That will turn our hydroxide into a good leaving group. Tosyl chloride is G, right? Now we have a tosylate. And that among our reagents also is, well, a strong bulky base, right? Because if we have a good leaving group and a strong bulky base, that will make elimination happen, giving us the the Hoffman, the Hoffman alkene product, right? The Hoffman elimination product, rather than the Zaitsev product. Zaitsev being the more substitute alkene. And since we have a potassium t-buoxide, which is a strong bulky base, this would do the exact elimination that we need. And if I'm looking at your answer now, having arrived at my answer, well, I see that the answer is B, G, A. You've simply indicated the reagents backwards. You have the correct answer, at least in terms of the reagents that you need to use. Just do B first, then G, then A, B, G. You've got them out of order. But you've got the right idea.